far below the sunlit waves that most of us know so well. Beneath the rhythmic swells and blue expanses that cover over 70% of our planet, there lies a realm that remains largely unexplored, mysterious, and alien to human understanding: the abyss of the oceans. A place where eternal darkness reigns and the environment is so hostile that it challenges the very definition of life itself. This is not the gentle world of coral reefs or kelp forests, but a cold, pressurized underworld that stretches for miles beneath the surface, where only the hardiest and most adapted creatures can survive. For centuries, this abyss has piqued the curiosity of scientists, explorers, and storytellers alike. But despite our advances in technology, it remains a place where much is left to be discovered. Welcome to the abyss, where the ocean descends into an eternal night, a domain as foreign as the surface of another planet. When we think of the ocean, most people picture the surface waters, clear blue expanses, gently lapping waves, and perhaps even the vibrant ecosystems found in coastal waters. These sunlit regions, known as the epipelagic zone, extend to around 200 meters, 656 feet, in depth. Below this point, sunlight starts to fade, and the temperature begins to drop dramatically. Past this threshold lies a different world, one where the familiar rules of life begin to break down. This world is defined by its layers of increasing depth, each with its own unique characteristics, and at the farthest reaches is the abyssal zone, the true abyss, where light cannot reach, and the ocean floor stretches out in vast, empty plains, broken only by towering mountain ranges and deep trenches. The descent into the abyssal zone begins far before we even reach the deepest depths. After the sunlit epipelagic zone, we enter the mesopelagic zone, which ranges from 200 meters down to around 1,000 meters, 3,280 feet. This is often called the twilight zone, as sunlight still penetrates, but only in faint, ghostly traces. Here, the water grows colder, and the pressure begins to mount. At these depths, strange creatures like the lanternfish and bristlemouth fish make their home, relying on the faintest glimmers of light to navigate and hunt. Bioluminescence, the ability of organisms to produce their own light, becomes a common feature, serving as a crucial adaptation in this dim, shadowed world. But it's below the mesopelagic zone, at depths beyond 1,000 meters, that the true abyss begins to unfold. First comes the bathopelagic zone, often referred to as the midnight zone. In this realm, which extends from 1,000 to 4,000 meters, 13,123 feet, no sunlight whatsoever penetrates. The waters are pitch black, and the only light comes from the eerie glow of bioluminescent organisms, casting an otherworldly radiance as they drift through the inky blackness. Temperatures here hover just above freezing, and the water pressure is immense, over 5,800 pounds per square inch, or 400 times the pressure at sea level. This is a place where the laws of nature seem to warp and twist under the weight of the ocean, where the concepts of light and warmth no longer apply. Life here takes on bizarre and often terrifying forms, and survival depends on adaptations that seem straight out of science fiction. Even deeper still lies the abyssopelagic zone, aptly named for the abyss itself. Ranging from 4,000 to 6,000 meters, 19,685 feet, this is the heart of the ocean's eternal night. Here, the pressure is beyond comprehension, up to 11,000 pounds per square inch, and the temperature hovers just above freezing, typically between 2 degrees Celsius and 3 degrees Celsius, 36 degrees Fahrenheit to 37 degrees Fahrenheit. This is a place where the ocean floor stretches endlessly, punctuated by steep cliffs, deep trenches, and underwater mountains. Some of these trenches, such as the Mariana Trench, plunge even further into the hadopelagic zone, the deepest part of the ocean, where depths can reach a staggering 11,000 meters, 36,000 feet. One of the most remarkable aspects of the abyss is its sheer size. The abyssal zone covers roughly 60% of the Earth's surface and makes up the majority of the ocean's volume. And yet, despite its vastness, it remains one of the least explored and least understood places on our planet. The deep ocean is not just another part of the sea. It is an entirely different world, a frontier that is as unknown and mysterious as the farthest reaches of outer space. In fact, we know more about the surface of the moon than we do about the abyssal plains. This is due in part to the extreme conditions that make exploration difficult. The crushing pressure, the frigid temperatures, and the absolute darkness that permeates the abyss. However, with advancements in technology, such as remotely operated vehicles, ROVs, and deep-sea submersibles, we are slowly beginning to peel back the layers of mystery that have surrounded this region for millennia. What we have discovered in the abyss is nothing short of astounding. Despite the hostile conditions, life not only exists here, but thrives in forms that seem almost too strange to be real. Gigantic, gelatinous creatures drift through the water, their translucent bodies glowing with bioluminescence. Enormous squid, with tentacles that stretch for meters, glide silently through the dark, hunting for prey. Meanwhile, the ocean floor is home to strange, spindly crabs and shrimp, which scuttle across the abyssal plains in search of food. There are creatures here that defy the very idea of life as we know it. Organisms that can survive in near-freezing temperatures and under pressures that would crush most living things. Some rely on chemosynthesis, a process by which organisms convert chemicals from hydrothermal vents into energy, rather than photosynthesis, which requires sunlight. This discovery revolutionized our understanding of life's possibilities, suggesting that life could potentially exist in similarly extreme environments elsewhere in the universe. But the abyss is not only a place of strange and fascinating creatures, it is also a place of awe-inspiring geological features. The ocean floor is not flat, as once believed, but is instead a landscape of towering mountain ranges, deep valleys, and immense plateaus. The Mid-Atlantic Ridge, for example, is an underwater mountain range that stretches for over 16,000 kilometers, 10,000 miles, making it the longest mountain range on Earth. Along this ridge and others like it, hydrothermal vents spew superheated water rich in minerals from deep within the Earth's crust. These vents create unique ecosystems, where life flourishes despite the extreme conditions. Here, bacteria feed on the chemicals released by the vents, forming the base of a food chain that includes everything from tiny worms to massive, tube-like creatures that can grow several feet long. As we descend deeper into the abyss, we also encounter the ocean's trenches, some of the deepest and most mysterious places on the planet. The Mariana Trench, located in the western Pacific Ocean, is the deepest known point in the world's oceans, plunging to a depth of nearly 11,000 meters, 36,000 feet, in the Challenger Deep. The pressure at these depths is unimaginable, more than 1,000 times the atmospheric pressure at sea level. And yet, even here, in this seemingly inhospitable environment, life can be found. In 2012, filmmaker James Cameron famously descended to the bottom of the Mariana Trench in a specially designed submersible, becoming the first person to make a solo dive to such depths. What he saw was a barren, alien landscape, with strange creatures moving through the water like something out of a dream or a nightmare. The abyssal zone is also home to a phenomenon known as marine snow. This snow is actually a continuous shower of organic matter that drifts down from the upper layers of the ocean. Composed of the remains of dead organisms, fecal matter, and other organic debris, marine snow serves as a crucial food source for many deep-sea organisms. As it sinks slowly through the water column, it is consumed by a variety of creatures, from tiny plankton to massive deep-sea fish. This constant rain of nutrients from above is one of the few reliable sources of food in the abyss, where traditional food chains, based on sunlight and photosynthesis, do not exist. Despite its remoteness and hostility, the abyss plays a vital role in the health of the planet as a whole. The deep ocean acts as a giant carbon sink, absorbing and storing vast amounts of carbon dioxide from the atmosphere. This process helps to regulate the Earth's climate and mitigate the effects of global warming. In addition, the deep-sea ecosystems found around hydrothermal vents and cold seeps are thought to play a role in the cycling of nutrients and minerals, which are essential to the functioning of marine ecosystems as a whole. The abyssal plains also serve as a repository for human activity, both past and present. Over the centuries, countless ships have sunk to the bottom of the ocean, their wrecks coming to rest on the abyssal floor. These wrecks, along with the remains of aircraft, submarines, and even satellites, create artificial habitats that are quickly colonized by deep-sea organisms. Moreover, modern human activities such as deep-sea mining and oil drilling pose significant threats to the fragile ecosystems of the abyss. The extraction of minerals and fossil fuels from the ocean floor has the potential to cause irreparable damage to these environments, which are already vulnerable to the effects of climate change. In the vast, dark expanses of the abyss, life has found a way to thrive against all odds. From bioluminescent creatures that glow in the dark to giant, gelatinous beasts that seem more like aliens than earthly organisms, the inhabitants of this eternal night have adapted to an environment that is as hostile as it is fascinating. Each new discovery in this shadowy realm pushes the boundaries of our understanding of life on Earth, and perhaps life beyond our planet. Into the abyss of the oceans, past the sunlit waves and the shimmering surface, we find ourselves entering a world that is as hostile as it is mesmerizing. The further we descend, the more the familiar conditions of life as we know it begin to unravel. Gone are the light-filled, colorful waters teeming with fish, coral, and marine plants. Instead, we find ourselves in a pitch-black, frigid expanse where the pressure is so intense it could crush a human body in an instant. This is the domain of the abyss, an environment so extreme that it seems almost uninhabitable. And yet, in the eternal night of the ocean's depths, life not only persists, but has evolved in remarkable ways to survive and thrive in these harsh conditions. But before we delve into the creatures that inhabit this realm, it's important to understand the sheer enormity of the challenges that life must overcome to exist in such an environment. The abyss of the oceans, encompassing the bathypelagic, abyssopelagic, and hadopelagic zones, presents a unique set of obstacles that make it one of the most difficult places for life to survive. These challenges can be grouped into several main categories: extreme pressure, frigid temperatures, the complete absence of sunlight, and the scarcity of food. Each of these factors alone would be enough to make survival difficult, but together, they create an environment that seems almost impossible to endure. Extreme pressure. A crushing weight, perhaps the most formidable challenge of the abyss, is the immense pressure. For every 10 meters, 33 feet, you descend into the ocean, the pressure increases by 1 atmosphere, the pressure we experience at sea level. By the time you reach the bathypelagic zone, at a depth of 1,000 meters, 3,280 feet, the pressure is already 100 times greater than at the surface. And as you descend further into the abyssopelagic zone at depths of 4,000 meters, 13,000 feet, and beyond, the pressure becomes nearly unimaginable, reaching up to 600 times the pressure at sea level. To put this in perspective, at these depths, the pressure is so intense that it would crush most man-made objects, let alone any organism not specially adapted to survive. A human without the protection of a submersible or a pressurized suit would be crushed almost instantly. Even modern submarines must be specially reinforced with thick, durable materials to withstand the forces at work in these depths. The pressure is not just a weight. It's a crushing force that squeezes the very molecules of anything it touches. How do organisms survive in this environment? The key lies in their unique adaptations. Many deep-sea creatures have soft, gelatinous bodies that allow them to withstand the intense pressure. Rather than being rigid, their bodies are flexible, which prevents them from being crushed. The tissues of these creatures are often filled with water, which is incompressible and helps to counteract the effects of pressure. Additionally, some organisms have developed specialized proteins and enzymes that are able to function under high-pressure conditions. These adaptations not only prevent the organisms from being crushed, but also allow their biological processes to continue in the extreme environment of the abyss. For example, the giant squid, one of the most iconic creatures of the deep, has a body that is primarily composed of soft, flexible tissue. Its large, bulbous mantle is filled with water, and its limbs are long and elastic, allowing it to move gracefully through the depths despite the immense pressure. The same is true for many of the fish that inhabit the abyss, such as the fongtooth or the black sea devil. These creatures have evolved bodies that can bend and flex under pressure, allowing them to navigate their dark, pressurized world with ease. In contrast, many organisms that live in shallower waters or on land rely on rigid, calcified structures such as bones or exoskeletons for support. In the abyss, however, these rigid structures would be a liability, as they would likely be crushed under the extreme pressure. As a result, many deep-sea creatures have evolved without these structures, relying instead on the fluidity and flexibility of their bodies to survive. Frigid temperatures. A world locked in ice. Another major challenge of life in the abyss is the temperature. Unlike the surface waters, which are warmed by the sun, the depths of the ocean are locked in a state of near-freezing cold. The temperature in the abyssal zone hovers just above freezing, typically between 2 degrees Celsius and 3 degrees Celsius, 36 degrees Fahrenheit to 37 degrees Fahrenheit. This cold is unrelenting and inescapable, as the absence of sunlight means there is no external source of warmth. The water here is icy, and any organism that wishes to survive must be able to cope with the constant cold in such an environment. The metabolic processes that sustain life slow down significantly. Cold temperatures reduce the rate at which chemical reactions occur, making it more difficult for organisms to generate energy and maintain their bodily functions. This is why many deep-sea creatures have evolved to live at a much slower pace than their counterparts in warmer waters. Their metabolisms are adapted to the cold, allowing them to conserve energy and survive in an environment where food is scarce and the cold is all-encompassing. Some creatures have developed special proteins known as antifreeze proteins, which prevent their bodily fluids from freezing solid in the icy waters. These proteins bind to ice crystals and prevent them from growing, allowing the organisms to maintain a stable internal environment even in near-freezing conditions. This adaptation is crucial for survival in the abyss, where the cold is as much a threat as the pressure. For example, the Antarctic toothfish, which inhabits the deep, cold waters around Antarctica, produces antifreeze proteins that allow it to survive in waters that are below the freezing point of freshwater. Without these proteins, the fish's blood and other bodily fluids would crystallize in the cold, leading to death. Similar adaptations are found in other deep-sea fish and invertebrates, allowing them to survive in the icy abyss. Additionally, many deep-sea creatures have evolved to have slow, steady metabolisms, which allow them to conserve energy in an environment where food is scarce. The cold temperatures reduce the need for frequent feeding, as the creatures can sustain themselves on smaller amounts of food over longer periods of time. This slow pace of life is a common theme in the abyss, where energy conservation is key to survival. The absence of sunlight. Life in the dark. Perhaps the most defining characteristic of the abyss is the complete absence of sunlight. Below 1,000 meters, 3,280 feet, no sunlight penetrates the water, and the ocean is plunged into perpetual darkness. This lack of light presents a significant challenge for life, as photosynthesis, the process by which plants and other organisms convert sunlight into energy, is not possible in the abyss. Without sunlight, there can be no plants, no algae, and no primary producers to form the base of the food chain. As a result, the traditional food chains that exist in the sunlit regions of the ocean break down, and life in the abyss must rely on other sources of energy in this lightless world. Many creatures have evolved to produce their own light through a process known as bioluminescence. Bioluminescence is the production and emission of light by living organisms, and it is a common adaptation in the deep sea. In the absence of sunlight, bioluminescence serves a variety of purposes, from attracting prey to deterring predators to facilitating communication between individuals. For example, the anglerfish, one of the most well-known inhabitants of the deep sea, uses a bioluminescent lure to attract prey. The lure, a glowing appendage that extends from the fish's head, dangles in front of its mouth, tempting smaller fish and other creatures to come closer. When an unsuspecting prey item approaches, the anglerfish snaps its powerful jaws shut, devouring its meal in an instant. This adaptation allows the anglerfish to hunt in the dark, where visual cues are scarce and prey is difficult to find. Similarly, many deep-sea squid and jellyfish use bioluminescence to confuse or startle predators. When threatened, these creatures can emit bright flashes of light, which momentarily blind or disorient their attackers, giving them a chance to escape. In the darkness of the abyss, where predators can strike from any direction, the ability to produce light is a valuable tool for survival. Bioluminescence is also used for communication in the deep sea. Many fish and invertebrates produce light patterns that are specific to their species, allowing them to identify one another in the darkness. This is particularly important for mating, as finding a mate in the vast, dark expanses of the abyss can be a daunting task. By producing species-specific light displays, individuals can signal their presence to potential mates, ensuring the continuation of their species. In addition to bioluminescence, many deep-sea creatures have evolved highly sensitive eyes that can detect even the faintest traces of light. While no sunlight reaches the abyss, the light produced by bioluminescent organisms provides enough illumination for some creatures to see. These animals have large, well-developed eyes that allow them to make the most of the limited light available. In some cases, their eyes are so sensitive that they can detect single photons, the smallest possible units of light. This extraordinary sensitivity gives them a significant advantage in the dark, allowing them to hunt, avoid predators, and navigate their environment with greater precision. However, not all creatures in the abyss rely on vision to survive. Many have evolved to live in complete darkness, either by developing other senses or by losing their eyes altogether. Some deep-sea fish, for example, have long, sensitive whiskers or barbels that allow them to detect vibrations and chemical signals in the water. These barbels function like antennas, picking up cues from the surrounding environment and helping the fish locate prey or avoid danger. Other organisms, such as certain species of shrimp and crabs, use specialized chemical receptors to taste the water, allowing them to detect the presence of food or other animals nearby. For those creatures that have lost their eyes, life in the abyss is a world of touch, taste, and sound rather than sight. These organisms rely on their other senses to survive in an environment where light is a distant memory. Scarcity of food. Surviving in a nutrient desert, perhaps the most pressing challenge for life in the abyss, is the scarcity of food. Unlike the sunlit regions of the ocean, where plants and algae form the base of a thriving food web, the abyss is a nutrient desert. Without sunlight to power photosynthesis, there are no primary producers to generate the energy needed to sustain life. As a result, the creatures of the abyss must rely on other, often scarce, sources of food to survive. One of the primary sources of food in the abyss is marine snow, a continuous shower of organic material that falls from the upper layers of the ocean. Marine snow consists of dead organisms, fecal matter, and other organic debris that drifts slowly down through the water column. This detritus serves as a crucial food source for many deep-sea organisms, which feed on it as it sinks to the ocean floor. As marine snow falls through the water, it is consumed by a variety of creatures, from tiny plankton to larger fish and invertebrates. However, by the time it reaches the deepest parts of the ocean, much of the organic material has already been eaten or decomposed, leaving only a fraction of the original material for the creatures of the abyss. This scarcity of food forces deep-sea organisms to be highly efficient in their feeding habits. Many species have evolved to consume a wide variety of food sources, from marine snow to the carcasses of larger animals that sink to the ocean floor. In some cases, deep-sea organisms rely on whale falls, the carcasses of dead whales that sink to the ocean floor, as a source of food. Whale falls create temporary oases of nutrients in the otherwise barren landscape of the abyss. When a whale carcass reaches the ocean floor, it is quickly colonized by a variety of organisms, including scavengers such as hagfish and crabs, which strip the flesh from the bones. As the carcass decomposes, it provides sustenance for a complex ecosystem of bacteria, worms, and other creatures, which can survive on the nutrients released by the whale for years or even decades. The abyssal zones of the ocean, we step into one of the most extreme and unearthly environments on the planet. This pitch-black expanse, so hostile that it seems devoid of life, is actually home to some of the most astonishing organisms on Earth. This hidden world, known as the abyssopelagic zone, exists at depths between 4,000 and 6,000 meters, 13,000 to 20,000 feet, where the crushing pressure, frigid temperatures, and absence of sunlight create conditions that seem impossible for life to exist. Yet, life not only survives here, but has adapted in extraordinary ways, transforming itself into biological marvels that defy the limits of our understanding. Evolution, ever relentless and patient, has shaped these organisms into unique forms, crafting intricate and bizarre adaptations to help them endure the abyss's extreme challenges. But how exactly do these creatures survive in this eternal night, where food is scarce, the environment is unforgiving, and darkness is absolute? This is where the evolutionary creativity of nature takes center stage. From bioluminescence to highly specialized feeding mechanisms, from symbiotic relationships with bacteria to remarkable reproductive strategies, life in the abyss offers a window into the power of evolution to craft beings that seem as though they belong to another world entirely. Let us embark on a journey into the depths, exploring the unique adaptations that enable creatures to survive in one of the most hostile environments on Earth. These adaptations are not merely survival mechanisms. They are testimonies to the versatility and tenacity of life itself. The wonders of bioluminescence. Lighting up the eternal darkness in a world where sunlight never reaches, creatures have evolved to create their own light. This is the miracle of bioluminescence, one of nature's most dazzling phenomena. Bioluminescence is the ability of organisms to produce light through chemical reactions within their bodies. For the inhabitants of the abyss, this is not merely an aesthetic feature. It is a crucial adaptation for survival. Bioluminescence serves a variety of functions, from hunting to communication to defense. For example, the infamous anglerfish uses a bioluminescent lure, which dangles from a protrusion on its head, to attract prey in the darkness. The light acts like a beacon in the deep sea's black expanse, enticing smaller fish and invertebrates to come close, unaware that the anglerfish lies just behind, waiting to snap its jaws shut around them. It's a predatory tactic finely tuned by evolution for a world where visual cues are nearly non-existent and food is rare. But bioluminescence isn't just for hunting. In fact, it's often a crucial tool for defense. Many deep-sea creatures can emit sudden bursts of light to startle predators or to confuse them, giving them a brief moment to escape. For example, certain species of deep-sea squid release glowing clouds of bioluminescent fluid when threatened, much like an octopus ejects ink. This brief flash of light can disorient predators long enough for the squid to vanish into the darkness. Other creatures use bioluminescence for communication, signaling potential mates or members of their species. For some species, specific patterns of light flashes are unique identifiers. Each blink or sequence a signature of the organism. In the abyss, where traditional senses like sight and sound are limited, these glowing displays serve as a crucial means of interaction. The cookie-cutter shark, a small but dangerous predator, has bioluminescent patches on its underside. These patches help it blend into the dim light filtering down from above when viewed from below, making it nearly invisible to prey. Yet, near its mouth, a patch of skin remains dark. When unsuspecting fish or squid swim close to investigate, the cookie-cutter shark swiftly bites out a circular chunk of flesh before darting away. These adaptations reveal the extent to which evolution has equipped these creatures to manipulate their environment. In a place where light is an invaluable resource, the ability to produce it is one of the most significant evolutionary tools in the deep sea. Extreme senses. Perceiving the unperceivable in the pitch-black darkness of the abyss, where the human eye would be utterly useless, many creatures have evolved extreme sensory adaptations that allow them to detect the slightest vibrations, chemical signals, or electrical impulses in their environment. These senses often seem otherworldly in their sophistication and precision, enabling deep-sea inhabitants to thrive in what would otherwise be an incomprehensible environment. One of the most remarkable examples of this is the barrel-eye fish, a creature with a transparent head and highly specialized eyes that can rotate within its skull. These eyes, rather than pointing straight ahead like most fish, are adapted to look upwards, allowing the barrel eye to detect the faint silhouettes of prey above. The transparency of its head ensures that its eyes are not obstructed by its own body, giving it an unobstructed view of potential meals. This fish essentially exists in a constant state of vigilance, looking up into the dim glow of the upper ocean, waiting to catch the faintest shadow of a passing animal that is in a similar vein. The viper fish, one of the most terrifying predators of the deep, has a long, needle-like body and oversized fangs that make it look like something out of a nightmare. Its massive teeth are so large that they don't even fit inside its mouth, and its jaws are hinged in such a way that it can snap shut on prey with incredible speed. But the real marvel of the viper fish lies in its ability to sense the slightest changes in the water around it. With specialized sensory organs, it can detect even the tiniest electrical impulses generated by the movements of other animals. This allows the viper fish to strike with deadly precision, even in complete darkness. Another sensory adaptation that has evolved in the deep sea is the use of chemical signals. Many deep-sea organisms, including some species of shrimp and crabs, rely on chemical receptors to taste the water, enabling them to detect minute changes in the chemical composition of their surroundings. This sense allows them to find food, identify mates, and avoid predators in an environment where vision is often unreliable or completely useless. In the abyss, where traditional senses are diminished by the absence of light, chemical perception becomes a vital tool for survival. Furthermore, certain species have evolved the ability to detect heat signatures in the cold darkness of the abyss. The ghost shark, also known as the chimera, is an ancient relative of sharks that inhabits the deep sea. It possesses specialized sensory organs called ampullae of Lorenzini, which can detect the faint electrical fields produced by other organisms. This ability is particularly useful in the deep ocean, where visual cues are absent, and many prey species are camouflaged against the dark background of the ocean floor. Feeding in the abyss. Strategies for survival. Finding food in the abyss is perhaps the greatest challenge for its inhabitants. Food is exceedingly scarce, and the creatures that live here have evolved an incredible array of strategies to exploit the few available resources. From opportunistic scavengers to highly specialized predators, the deep sea is home to an extraordinary variety of feeding strategies. One of the most well-known strategies is sit-and-wait predation, exemplified by creatures like the anglerfish. In a world where energy must be conserved, it pays to be patient. Anglerfish are experts at this, remaining motionless in the water while their bioluminescent lure dangles in front of their mouths. When a potential meal swims by, drawn to the glowing light, the anglerfish strikes with lightning speed, swallowing its prey whole. This strategy allows the anglerfish to conserve energy, only exerting itself when there is a guaranteed meal within reach. Other creatures, such as the gulper eel, have evolved to take advantage of whatever food comes their way, no matter how large or small. The gulper eel's enormous mouth, which can open to an astonishing size, allows it to swallow prey that is nearly as large as itself. Its long, ribbon-like body can stretch to accommodate large meals, making it one of the most opportunistic feeders in the deep sea. This adaptation is crucial in the abyss, where food is unpredictable and creatures must be prepared to eat whatever comes their way. Scavenging is another key survival strategy in the deep sea. When a large animal, such as a whale, dies and sinks to the ocean floor, it becomes a temporary oasis of nutrients in an otherwise barren landscape. These whale falls attract a variety of scavengers, from hagfish to giant isopods. These organisms can survive on the nutrient-rich remains of the whale for months or even years, taking full advantage of the rare bounty. The hagfish, in particular, is an ancient creature that has remained virtually unchanged for hundreds of millions of years. It is a master scavenger, able to burrow into decaying flesh and consume it from the inside out. Its slimy, eel-like body allows it to navigate the tightest spaces within a whale carcass, making it one of the most effective scavengers in the deep sea. In addition to scavengers, the abyss is also home to a variety of filter feeders, such as deep-sea sponges and certain species of jellyfish. These creatures drift through the water, using specialized structures to capture tiny particles of organic matter, including marine snow, which consists of detritus and decaying material that drifts down from the upper layers of the ocean. Filter feeders play a crucial role in the deep-sea ecosystem, as they help to recycle nutrients and sustain other forms of life. Symbiosis and survival. Life in the deep sea, survival is often a collaborative effort. Many species have evolved symbiotic relationships with other organisms, forming partnerships that allow them to thrive in the extreme conditions of the abyss point. One of the most fascinating examples of symbiosis in the deep sea is found in the relationship between certain species of fish and bioluminescent bacteria. These bacteria, which live in specialized light organs on the fish's body, produce light that the fish can use for a variety of purposes, from attracting prey to finding mates. In return, the bacteria are provided with a safe place to live and a steady supply of nutrients. This mutually beneficial relationship allows both the fish and the bacteria to survive in an environment where resources are scarce and danger is ever present. Another remarkable example of symbiosis is found in the giant tube worms that inhabit hydrothermal vent ecosystems. These worms, which can grow to lengths of over 2 meters, 6.5 feet, have no digestive system of their own. Instead, they rely on chemosynthetic bacteria that live inside their bodies. These bacteria convert the chemicals released by the hydrothermal vents, such as hydrogen sulfide, into energy, which the worms then use to sustain themselves. This relationship is a perfect example of how life can adapt to even the most extreme environments, finding ways to thrive in conditions that would be lethal to most other organisms. In the absence of sunlight, where photosynthesis is impossible, chemosynthesis becomes a vital source of energy for deep-sea communities. This process, which involves the conversion of inorganic compounds into organic matter, fuels entire ecosystems around hydrothermal vents, supporting a wide variety of organisms, from tube worms to crabs to clams. These ecosystems are some of the most unique on Earth, demonstrating the incredible adaptability of life in the face of adversity. Reproductive strategies in the abyss. Ensuring the next generation in the deep sea, where encounters between individuals are rare due to the vast distances and sparse population, reproduction poses a unique set of challenges. Many species have evolved specialized reproductive strategies to ensure the continuation of their species in the harsh conditions of the abyss point. One of the most unusual reproductive adaptations is seen in the deep-sea anglerfish. In this species, the male is much smaller than the female and plays a very different role in reproduction. When a male anglerfish encounters a female, a rare event in the vastness of the deep sea, he bites on her body and becomes permanently fused to her. Over time, the male's body atrophies, and he becomes little more than a pair of testes, providing the female with a continuous supply of sperm. This parasitic form of reproduction ensures that the female can fertilize her eggs whenever she is ready, without needing to find a mate again. Other deep-sea creatures, such as certain species of fish and squid, practice broadcast spawning, releasing their eggs and sperm into the water in massive quantities. In the abyss, where mates may be few and far between, this strategy increases the chances that some of the offspring will survive to adulthood. The sheer number of eggs and sperm released ensures that, even in the face of predators and other challenges, at least a few individuals will make it to maturity. Some species, such as the giant deep-sea octopus, display remarkable parental care, with the female guarding her eggs for months or even years. During this time, the female does not eat, dedicating all her energy to protecting her offspring. When the eggs finally hatch, the female dies, having sacrificed her life to ensure the survival of the next generation. These reproductive strategies reflect the harsh realities of life in the abyss. In an environment where resources are scarce, mates are difficult to find, and the odds of survival are slim. Evolution has crafted unique solutions to ensure that life continues to thrive, even in the darkest depths of the ocean. The abyss, a final frontier of evolution as we explore the depths of the abyss. We are continually reminded of the incredible power of evolution to shape life in the most extreme environments. From bioluminescence to extreme sensory adaptations, from symbiotic relationships to specialized reproductive strategies, the creatures of the deep sea have evolved to survive in a world that seems inhospitable to life. These adaptations are not just remarkable in their ingenuity, they are a testament to the resilience of life itself. The abyss may be a place of eternal night, but within its depths, life flourishes in forms that are as bizarre as they are beautiful. The evolutionary marvels of the deep sea offer us a glimpse into the boundless creativity of nature, reminding us that no matter how harsh the environment, life will always find a way to survive. The vast abyssal depths of the ocean remain one of the final frontiers on Earth, an uncharted wilderness that stretches across an alien landscape hidden beneath miles of water. Here, in the abyssopelagic zone, where the pressure is intense, temperatures hover just above freezing, and sunlight is but a distant memory, life has found a way to thrive in forms unimaginable. However, perhaps the most fascinating aspect of this deep ocean world is the intricate web of ecosystems that exist within this inhospitable environment. These ecosystems, forged by the relentless pressures of survival, represent one of the most complex and enduring mysteries of the natural world. Unlike the more familiar ecosystems on land or in shallow oceans, which depend on sunlight as the primary source of energy, the ecosystems of the abyss are driven by entirely different forces. From hydrothermal vents that create oases of life in the darkest reaches of the ocean floor to whale falls that provide a feast for scavengers in an otherwise barren landscape, the deep-sea ecosystems are as varied as they are unique. But what exactly are the dynamics at play in these hidden ecosystems? And how do the inhabitants of the abyss sustain themselves in such an extreme environment? Join us as we journey into the depths to explore the ecosystems of the eternal night. From the strange creatures that call these places home to the powerful chemical processes that sustain life without sunlight, these deep-sea ecosystems reveal a world of stunning biodiversity and intricate balance. The abyssal seafloor. A desert of life at the base of the ocean lies the abyssal plain, one of the flattest and most expansive landscapes on Earth, covering more than 50% of the planet's surface. This desolate expanse, which lies at depths between 3,000 and 6,000 meters, may seem devoid of life at first glance. To the naked eye, the abyssal plain might appear as an endless, barren desert of mud and silt, where the cold and crushing pressure should prevent any form of complex life from surviving. However, beneath this unassuming surface exists a delicate ecosystem. Life in this part of the ocean is sparse but highly specialized, and the creatures that inhabit the abyssal plain have evolved unique adaptations to survive in these extreme conditions. One of the most vital components of this ecosystem is marine snow, a continuous fall of organic material from the upper ocean that rains down on the abyssal plain like snowflakes. Marine snow is composed of dead organisms, fecal pellets, decaying plant matter, and other microscopic debris, and it serves as the primary food source for many organisms in the abyssal zone. While individual particles of marine snow are tiny, over time they accumulate, providing essential nutrients for deep-sea creatures like sea cucumbers, brittle stars, and giant isopods. These creatures play a crucial role in the abyssal ecosystem by recycling organic material and facilitating nutrient flow. For example, the sea cucumber, one of the most common animals on the abyssal plain, feeds by sifting through the sediment, extracting organic particles from the mud. Similarly, giant isopods, which resemble oversized woodlice, scavenge the ocean floor, feeding on marine snow and the remains of dead animals. Together, these organisms form the backbone of the abyssal ecosystem, sustaining life in an environment where food is scarce and unpredictable. Yet, life on the abyssal plain is precarious. Food is in constant short supply, and competition is fierce. The creatures that inhabit this region must be highly efficient in their energy use, and many have developed slow metabolisms to conserve energy between meals. Some species can go months, even years, without food, relying on stored energy reserves to survive. In this nutrient-poor environment, every scrap of organic matter is a precious resource, and the delicate balance between predator and prey ensures that the ecosystem continues to function. Hydrothermal vents. Oases of life in the abyss. One of the most extraordinary discoveries in the history of ocean exploration was the existence of hydrothermal vent ecosystems, located at the intersection of tectonic plates on the ocean floor. These ecosystems, which are found at depths of 2,000 to 3,000 meters, are powered not by sunlight, but by the heat and chemicals emitted by the Earth's crust. This discovery revolutionized our understanding of life in the deep sea, revealing that entire ecosystems could exist independent of solar energy. Hydrothermal vents form when seawater seeps into the Earth's crust through cracks in the seafloor. As the water sinks deeper, it is heated by magma and reacts with the minerals in the rocks, becoming rich in chemicals such as hydrogen sulfide, methane, and other compounds. This superheated, mineral-laden water is then ejected back into the ocean through vents, creating towering chimneys known as black smokers, which spew out plumes of dark, hot fluid into the frigid waters of the deep sea. While these hydrothermal vents might seem like toxic environments, filled with boiling water and sulfuric chemicals, they are actually thriving ecosystems. The key to life in these extreme conditions is chemosynthesis, a process by which bacteria convert the chemical energy from vent fluids into organic matter. These chemosynthetic bacteria form the foundation of the hydrothermal vent ecosystem. Much like photosynthetic plants and algae form the base of food chains in sunlit environments. The bacteria themselves are extraordinary organisms, capable of surviving in temperatures that can exceed 400 degrees Celsius (750 degrees Fahrenheit) near the vent openings. They live inside the tissues of animals like giant tube worms, which have no digestive system of their own and rely entirely on their bacterial symbionts for nutrition. In exchange for providing the worms with nutrients, the bacteria receive a stable home within the worm's body, as well as a steady supply of chemicals from the vent fluids. The towering tube worms, which can grow up to 3 meters, 10 feet, in length, are among the most iconic creatures of the hydrothermal vent ecosystem. Their bright red plumes, which they use to absorb chemicals from the water, stand out in stark contrast to the otherwise dark and barren seafloor. These worms, along with other vent-dwelling organisms such as vent crabs, mussels, and snails, form a complex and diverse community that thrives in the inhospitable depths of the ocean. What makes hydrothermal vent ecosystems even more remarkable is their resilience. These ecosystems are often found in areas of intense geological activity, where tectonic shifts can cause vents to open and close, altering the flow of chemicals and destroying the delicate balance of life. Yet, despite these challenges, hydrothermal vent communities are incredibly dynamic, with organisms quickly colonizing new vents and adapting to the ever-changing conditions. Cold seeps. Slow oases of life. While hydrothermal vents are dramatic and fast-paced environments, cold seeps represent a slower, but no less fascinating, ecosystem in the abyss. Cold seeps are areas on the seafloor where hydrocarbons like methane and hydrogen sulfide slowly seep out of the sediment, providing a stable, long-term energy source for deep-sea organisms. These seeps are often found near continental margins, at depths ranging from 500 to 7,000 meters, and they support a diverse array of life. Like hydrothermal vent ecosystems, cold seep communities rely on chemosynthetic bacteria to convert the energy from chemicals into organic matter. These bacteria form the base of the food chain and provide sustenance for a variety of creatures, including clams, mussels, and polychaete worms. Many of these animals have symbiotic relationships with chemosynthetic bacteria, much like the tube worms of hydrothermal vents. The bacteria live inside the tissues of their hosts, providing them with nutrients in exchange for a stable environment and a supply of chemicals. Cold seeps are particularly notable for the presence of methane hydrates, crystalline structures that trap methane gas within water molecules. These hydrates can form large deposits on the seafloor, creating a unique habitat for methane-eating bacteria and the animals that rely on them. Over time, these ecosystems can create extensive carbonate mounds and reef-like structures, which provide additional habitats for deep-sea organisms. While cold seeps are less geologically active than hydrothermal vents, they are still dynamic ecosystems. The slow release of chemicals from the seafloor creates a stable environment for long-lived species, some of which can live for decades or even centuries. For example, certain species of cold seep mussels have been known to live for more than 100 years, making them some of the longest living animals in the deep sea. The cold seep ecosystem is a testament to the adaptability of life in the abyss. Even in the absence of sunlight, organisms have found a way to thrive by harnessing the chemical energy seeping from the Earth's crust. These ecosystems provide a glimpse into the resilience of life in the deep sea, where survival is often a matter of adapting to the slow, steady flow of energy from below. Whale falls, temporary bounties in the abyss, while hydrothermal vents and cold seeps provide long-term sources of energy for deep-sea ecosystems. Another phenomenon offers a more temporary, but equally important burst of nutrients to the abyssal plain, the whale fall. When a whale dies and its massive body sinks to the ocean floor, it creates a feast for scavengers and a complex ecosystem that can last for decades. A whale fall represents a rare but significant event in the deep sea, where food is scarce and unpredictable. As the whale's carcass descends into the abyss, it attracts a variety of scavengers, including hagfish, crabs, and giant isopods, which quickly begin to consume the soft tissues of the whale. These initial scavengers strip the carcass of its flesh within weeks, leaving behind only the bones. However, the story of the whale fall does not end there. The bones themselves become a habitat for specialized organisms that can survive on the remaining nutrients. Bone-eating worms, known as ostacs, are one of the most remarkable creatures to colonize whale falls. These worms burrow into the bones, secreting acid to dissolve the calcium and access the fats and oils inside. Over time, the ostax worms can completely consume the bones, leaving behind only traces of the once great whale. Whale falls create a temporary but highly productive ecosystem that can support a wide variety of organisms over several stages of decay. In the first stage, scavengers consume the soft tissues, while in the later stages, bacteria and other microorganisms break down the remaining organic matter, providing food for filter feeders and other deep-sea creatures. This process can take decades to complete, providing a steady source of nutrients in an otherwise barren landscape. The future of abyssal ecosystems. As we continue to explore the depths of the ocean, we are only beginning to understand the complexity and diversity of the ecosystems that exist in the abyss. The deep sea remains one of the most mysterious and least explored regions on Earth, with vast areas of the ocean floor still unmapped and unstudied. Yet, the ecosystems we have discovered so far reveal a world of astonishing adaptability and resilience, where life has found a way to thrive in the most extreme conditions. However, these ecosystems are not immune to the impacts of human activity. Deep-sea mining, climate change, and pollution pose significant threats to the delicate balance of life in the abyss. The extraction of minerals from the seafloor, in particular, could have devastating consequences for hydrothermal vent ecosystems, while rising temperatures and acidification could alter the chemical dynamics of cold seeps and other deep-sea habitats. As we venture further into the abyss, it is crucial that we approach this fragile and mysterious world with care. The deep-sea ecosystems that have evolved over millions of years represent some of the most remarkable and unique environments on our planet. By protecting these ecosystems, we not only preserve their biodiversity, but also safeguard the invaluable scientific insights they offer into the resilience of life on Earth. The abyss may be a realm of eternal night, but within its depths, life flourishes in ways that continue to astonish and inspire us.